Hey, let's go.
Hi, welcome to today's class. Welcome to Formula Academy. And today's class we'll be talking about chemistry. And the topic we'll be talking today is mixtures. So many people are wondering why do I always hold the hammer. I usually hold this hammer because I don't like wasting people's time, because I like hitting the nail on the head. So let's go. So today's topic we are talking about mixtures. So what are mixtures? Mixtures is a combination of two or more substances in which each of the substances can still retain their distinct identity or properties. So this is the definition of mixtures. Mixture is a combination of two or more substances in which each substance still retains its distinct identity. So example of mixture. One of the examples of mixture that is very common is hair. The hair you see around, they are mixtures, and the constituents of this hair are one, nitrogen, and this nitrogen that you are seeing here, NQ, has 78% in air. Then the next one, move on to what? Oxygen. Oxygen has what? 21% in air. Then we have carbon dioxide, which is CO2, which is 0.03% in air. So when you add 78 plus 21 plus 0.03, you have 99.03. So when you subtract that 99.03 from 100, you will have 0.97. So that 0.97 is not the percentage of noble gases, water vapor, and dust in air. So these are the constituent of hair in a mixture. So now we move on to the next example of mixture, which is brass. Brass constitutes of what? Copper and tin, which is Cu and Zn. Then the next type of example of bronze is example of mixtures is bronze, and it consists of what? Copper and tin, which is Cu and Sn. So move on to the next example of is what? Seawater. Seawater consists of water, mineral salt, dissolved gases, and bacteria. So most people will wonder why seawater is always salty, because it's what? It consists of both mineral salt. So seawater is always salty. Next type of mixture is urine. Urine, the normal urine that human pass out or animal pass out, is an example of mixture, and that constituents are urine, water, and mineral salt. So the popular example of mixtures is the crude oil, which is the petroleum. It consists of the various hydrocarbon. Crude oil consists of the various hydrocarbon that you know of, which are heavy oil, gas oil, petrol, bitumen, naphthalene, kerosene, and gases. So these are the constituents of crude oil, because crude oil is a mixture. So this one can only be separated by what we call fractional distillation. Fractional distillation is what is used in separating all these constituents from crude oil. So we're moving on to the types of mixtures. So the types of mixtures are that classified based on one, number of phase coexisting, and the sizes of what? Particles. Under number of phase coexisting, we have what we call homogeneous and heterogeneous mixtures. What is homogeneous and heterogeneous mixture? Homogeneous mixture is a mixture in which the composition are uniform. An example of that mixture is table salt plus water. So when you mix salt and water together, you find out that there is a uniformity. When you mix table salt and water together, there's a uniform that it brings out. So that's an example of what we call homogeneous mixtures. Then move on to what heterogeneous mixtures. So what is heterogeneous mixture? Heterogeneous mixture is a mixture in which the composition are not uniform, and a good example of such mixtures is the mixture of oil and water. This is usually why oil and water cannot mix together, because they are heterogeneous mixture. So remember to do what size of particle. Based on the size of particle, we have solution, suspension, and colloids. So in our next class, I'll be talking about solution, suspension, and colloid. I'll be talking about those three examples, other sizes of particle. So there's one mixture I want you to know about. It is called isotropic mixture. This type of mixture is a mixture that have what we call constant boiling point. It has what we call constant boiling points, just like pure substances. Pure substances has constant boiling points. So in our next class, I will be talking more of these isotropic mixtures. So before we go, please do well to subscribe to our YouTube channel, Formula Academy, to our TikTok, Formula Academy, because I want YouTube and TikTok to push this video to a large number of persons. So it is all depending on you. It depends on your subscription, it depends on your comment, it depends on your like, and it depends on you sharing it. So please do well to subscribe. See you in the next class.